diuretic. Like for example, coffee is diuretic. Tea is diuretic. Now, what have you observed when you take this in? Sikad ihi, di ba? Why? Now, the role of diuretic substances is to counteract the effect of antidiuretic hormone. Which, of course, instead nga, the water would be returned back from the kidneys to the circulation or to the blood. Ang nahitabo sa diuretic, more water that would be retained in the kidneys. Less would be in the circulation. So that's why sikad ihi. It's because more of this water would be retained in the kidneys. Say, mag-inom kang beer. Yung sikad ihi. Of course, I'm not telling you to drink that. So in other words, it counteracts these diuretic substances or diuretic beverages would counteract the effect of antidiuretic hormone. Now, this antidiuretic hormone or vasopressin, which is of course the specific example of our primary structure protein, would determine as to how much of this water would go back to the circulation from the kidneys. Okay? So that regulates as to how much. Because as much as possible, class, as much as possible, water in the blood must be regulated. Are you with me? Because what will happen if water would be lesser in the blood now? Lesser than what is being required or what is the normal percentage. What will happen? Hypertonic. Our blood will become hypertonic because there will be, of course, the solute remains the same, but there is decreased solvent. So, medyo nilapot imong dugo. Nga imuhang plasma. Why? Because of lesser water. Ang tendency, your cells would be surrounded with hypertonic solution. So, the tendency there, the water in the cells will get out. And the cells will shrink. And you will suffer, of course, dehydration. D means removal. Removal of water from the cells. So, that is what happened. If we keep drinking all those diuretic beverages, coffee, Coke, mga alcoholic beverages, beer. Now, sooner or later, you will be suffering from such. Your blood will become hypertonic because more water will be retained in the kidneys rather than in the blood. More will be thrown out in the kidneys instead of regulating or returning them back to the circulation. So take note of that, boys. Because sometimes you are tempted to drink. Okay? So, that will be the tendency. Now, even mga coffee drinkers, tea drinks, iced tea. Remember, these are diuretic, which will counteract with vasopressin or antidiuretic hormone. Okay? Now, another we have oxytocin. Now, oxytocin affects contraction. So, that is another primary structure protein that affects contraction of the uterus in the childbirth. That's what I have said. What causes the expulsion of the baby is because of the contraction of the smooth muscles of the uterine wall to expel the baby out from the womb of the mother. So that is, now say kanang kuan, kanang say tawag kanang, say when you are about to deliver and then there is no labor, what induces labor is the oxytocin actually. What makes it painful? Kanang tawag nila labor. It's because of the increasing secretion of oxytocin. And that induces the labor. However, there are some times in which the mother who is about to give birth cannot feel or cannot experience labor. So that's why naay injection. Ina-injectionan. Induced labor, we call that. What is being induced is this hormone, the primary structure, oxytocin. That is being induced. So, there would be increasing contraction of the smooth muscles of the uterine wall. That is facilitating the expulsion of the baby out from the tummy, from the womb. Okay? So, oxytocin, vasopressin, they belong to insulin or primary structure proteins. Okay, the same is true with, of course, you have the expulsion of the milk out. What ejects the milk? It's because of that. So you have the muscles of the breast that aid in the secretion of milk, contraction of the uterus in childbirth, and the muscles of the breast. So our breast is muscle. Now, what helps the expulsion of the milk in the breast is the oxytocin, and that is stimulated with suction. Manual, very good. So using the suction, so that is to aid or stimulate the oxytocin production. It stimulates the smooth muscle in the muscle in the breast for the expulsion of the milk. Okay, another we have secondary structure. Now, as what I have said, secondary structure is helical. So I have here helical structure. This is the most common type of secondary structure. Alpha helix and beta pleated sheath. So you have the alpha helix structure. Spiral like this, spiral. And then beta pleated sheath. So you have the polypeptide chain aligned parallel to each other. Parallel. Or anti-parallel like this. So this is an example of alpha helix. Alpha helix spiral. So like that, over DNA. And of course, the proteins. The proteins in which our DNA is interacting with, like for example, mga histones. They are secondary proteins. Spiral, arranged in a spiral.